everybody, I'm Professor Rad, and today we're going to talk about summarizing information that's presented to us in a math problem. So the goal of this video is not necessarily to solve problems, but to organize information in a way that will be helpful when we then need to go solve problems. I think of this a lot like in cooking. Before you make a big meal or start in on a recipe, they'll call it like mise en place, which means to like put into place, where you just sort of like organize all of your ingredients. You do all the like prep work beforehand, got everything in place so that when you start to cook or create a meal, everything is there and you're not like running back and forth and looking for ingredients while other things burn on the stove, right? You want everything accessible at the beginning. So that's what we're going to be looking at today in this video, is how do we do the prep work to help us to solve some word problems in the future. So you can see I've got a bunch of highlighters here because these can be really helpful, and also a pen. So I'm going to just work through this. I'm not really going to explain what I'm doing until the end of the video or at the end of the example. I'm just going to work through this as if I myself were working through this problem from the get-go. So the first thing I'm just going to read through. So it says a millennial is a person born between the early 80s and the early 2000s. In 2019, roughly 34% of American adults were millennials. In the same year, one study reported that 62.2% of American adults owned a home, while another indicated that 29% of American adults have a tattoo. An article published the same year reported that 78.2% of American adults were millennials or homeowners, and that the proportion of American adults who were tattooed millennials was 0.136. Summarize this information. Okay, so as I was reading through, there's some stuff about millennials, some about owning a home, and others with a tattoo. So I might do something like 34% of American adults were millennials. Let's see, we've got owning a home. And then tattoo. Okay, so we have millennials, homeowners, tattooed, and then millennials. Okay. All right, so what I've done with the highlighters here, some people like highlighting, some people writing or like writing off on the side better. I kind of depends on if I have my highlighters handy or not. So this might be one way that I choose to summarize this, and I might stop here, or I might write some stuff off on the side. So before I write the stuff off on the side, what I'm going to point out is I tried to keep similar information in the same color, right? So this first part, I had millennials in the orange. So then when millennials showed up later, I made that the orange. Homeowners was in purple, so that showed up there. And then tattoo was in green. So if you notice there's some repeated information, if you're using a highlighter, it can be helpful to use the same color for those components. If I were writing this out on the side, I might do the following. So I might write it out as a summary as well to say, like, yeah, I might just do 4%. And then okay, so I might summarize the information in this way. On the top of this line, I have that sort of single percentage information. So I've got 34% of Americans are millennial, 62.2% own a home, and 29% are tattooed. And then underneath that line, I have some combined information. So we've got millennial or homeowner, we've got that percentage, and then tattooed millennials, we have that percentage here. One of the reasons that this is very helpful is that if I don't highlight or if I don't write stuff off on the side, if I'm always coming back to the paragraph, it's like I'm doing two things whenever I come to the paragraph. I am parsing out all of that text while also looking for the information that's relevant to what I'm solving. And I've also kind of got like a pocket of my brain thinking about the problem I'm solving as well. Whereas when you highlight stuff in the same color, it helps to remove that needing to parse out all of this text each time. Or if you write it out on the side, it does the same thing. It kind of organizes stuff so it's here when you need it, and you don't need all this like unhighlighted stuff. That stuff is unnecessary. An extremely common mistake, in fact, it happened just this semester on my statistics test, is that there's a tendency to link the wrong number with the wrong bit of information. So for example, if I hadn't highlighted or written to the side, a common mistake would be seeing millennial and 62.2 close to each other. And so just applying this number to that word, because again, you've got a lot of processing going on once you go to solve a problem. Like you've got formulas in mind, you've got where you're going to plug numbers in, you've got like a process that you're doing to problem solving, you've got all this distracting information you don't need. And so your brain is like, oh, millennial 62.2, got it. Okay. So by highlighting in the same color, it helps you join the right number with the right information, or by putting it off to the side, that helps as well. So I mentioned my statistics class. This is a common type of problem you might see in a stats class or probability. I also see this in my like concepts of math class. You might get like an info dump of just a lot of information at once. So let's look at another question that I specifically pulled from a stats class, because sometimes when you're reading through a word problem, you might not know the full context of what's going on, but you can still summarize the information. So I want to show you what that looks like. Okay. So, like I said, this is an example from my statistics class, but I was inspired to include this in our arithmetic course because it shows up in our statistics class. But also, I remember as a student having difficulty, especially like in an algebra class, where there'd be a problem where I wasn't sure about what all the pieces of information meant. Like I might not know what a displacement volume was, but here I was needing to find that information to plug into a function or a formula. So you can still gather information even if you don't know what all of the terms mean. You can at least sort it, and then maybe later there will be some context provided to help. So in this example, it says, Wriggles Gum Company claims that the pieces of gum it produces are 1.55 millimeters thick on average, okay, with a standard deviation of 0.13 millimeters. Okay. A machinist at the company believes that one of the machines might be broken, which would result in improperly sized pieces of gum. He finds a sample of 42 pieces of gum and determines that they have an average thickness of 1.60 millimeters. The machinist conducts a two-tailed test at the 5% level. Okay, so as I'm reading through this, there are some things that I know what they mean and some things that I'm like not sure what they mean. So for example, 1.55 millimeters thick on average, I kind of have a sense of what that means, right? That's on average. How big are the pieces? I don't know what standard deviation means, right? I mean, I do, but for for the context here, right? If I'm just approaching this problem, standard deviation is like a field-specific term that I may not know, and that's okay. I just know that okay, whatever it is, it's 0.13 millimeters. Okay, cool. So we think the machine might be broken. So they find sample of 42 pieces of gum. Okay. And then they have an average thickness of 1.60 millimeters. Okay, and then this whole piece, I ran out of, oh, I do have another highlighter. I just have to reach across to get it. There we go. The machinist conducts a two-tailed test at the 5% level. I have no clue what this sentence is telling me. Not at all. But we'll just, it's a number, so let's highlight it, right? Okay. So we went through, we've kind of highlighted the information or thought about information that's going to be relevant. And now let's see what it's saying here. So A says there are 3 types of tests that can be conducted: a left-tailed test, a right-tailed test, and a two-tailed test. Which type of test did the machinist conduct? So when I'm seeing this, I remember that I saw that somewhere kind of at the end, two-tailed. I didn't know what that meant, and I still don't know what it means, but it's one of my options here, so we're going to say two-tailed. So if I end up taking a statistics class, I'll learn what this means, but for our purposes of like summarizing information, I just am identifying it and pulling it out. Then it says there are 2 levels at which a test can be conducted, the 1% and the 5%. So I remember seeing a percent. We've got a 5% level. So we've got a 5% level. All right. And then it says to solve this type of problem, you need to know an average, a sample's average, how big the sample was, and a standard deviation, which is information about how spread out the data values are. Okay, so it's telling me what a standard deviation is, because I know what an average is, or have a sense of that anyway. Identify these 4 values. Okay, so what I'm going to do is I'm going to write them out on the sides, kind of like an answer bank here. I need to know an average, a sample's average, how big the sample is, and a standard deviation. Okay. So I noticed that there are 2 averages. So I'm going to deal with those last so I can like kind of figure out what they are. How big it is, how big the sample is. That looks like what I have in purple here. Right? There's a sample of 42 pieces of gum. So that's how big it is. It's 42 pieces of gum. And then standard deviation, that's what I put in pink up here, 0.13 millimeters. Okay. Then we've got these 2 averages. So that's the green, 1.55 millimeters thick on average. And then they have an average thickness of 1.60 millimeters. Okay. So now I have to figure out which of these is an average and which of these is an average that refers to the sample. So this just says Wriggles Gum Company claims that the pieces of gum it produces are 1.55 millimeters thick on average. And then this one, he finds a sample of gum and determines they. So the they is referring to the sample here. So this would mean that the sample has an average thickness of 1.60. So that's the sample's average, must be. So 1.60 millimeters. And so the other average must be the other average, 1.55 millimeters. Okay, so here I've summarized all that information that was provided to us, kind of put those numbers out to the side. So you can see why if I were plugging into a formula and the formula had an average and a samples average, how going back to this paragraph, in the process of seeking out which number is which number, my brain's already overloaded with the formula that I might be plugging into. I mean, identifying which of those two to me is a process enough in and of itself without having anything else going on. So writing out a summary of information can really be helpful in solving problems, especially problems like this where there's words that I don't know quite what they mean, as well as things that are similar, like these two averages. And to me, that's one of the really important aspects of problem solving, is knowing how to identify things and sort things out. And that's really what we're practicing here, so that when we get to a class like statistics or algebra, we're accustomed to reading through and sorting stuff out. Right? And then we can start to apply next level problem solving after that. So I have one more example, which should have some more, kind of more of a combination of some things that we might have heard before, some things that might be new. And in this case, we're going to have, kind of like we had two averages here. This next example, we're going to have like two similar things, but that are also different, kind of like how we had two similar averages, but they were different averages for things. So let's go look at that last example. All right, so for our third example, it says, George contemplates investing the $15,000 he received from an inheritance. He has two investment opportunities to consider. The history of stock A indicates that his investment should grow at a rate of 12%, compounded 5 times annually. The history of stock B indicates that his investment would grow at a rate of 11.9%, compounded monthly. Summarize this information in the table below, and the investment rate should be given in decimal format. Okay. So that's a lot of information. By the way, this is a problem that comes from an algebra course, but you could also see a question like this in a like concepts of math class where you're dealing with different interest rates. So there are two stocks that we're investing in. So let's focus on stock A. So we've got stock A indicates that it should grow at a rate of 12%, and then it's compounded 5 times annually. So just to provide some context, what compounded means here is that, like if you make an investment, what they're going to do is periodically they'll look at the money in the account, and then based on your interest rate, you're going to earn like some extra money for like saving it, for example, based off the amount you have in your account. So if it's compounded 5 times annually, what that means is at regular intervals throughout the year, 5 times during the year, they will look at how much money is in the account and then add that interest rate to it. So that each time you go to add interest, the base that you're earning the interest on is growing because it's got the previous compounding's interest added to it. As opposed to like if you add all the interest at the end of the length of an investment, then you're just adding it off of that base investment, so it grows more slowly. Okay, so that's stock A. I'm doing in red here. So we've got the investment rate, and it says the investment rate should be given in decimal format. So we have a rate of 12%. So remember to go from percentage into decimal, you move the decimal point 2 spots over. So if I have 12%, that's like 12.0, and I'm going to move it 2 places over. So the investment rate is going to be 0.12. Then times compounded annually, it's compounded 5 times annually, so 5 times. All right, let's do the same thing for stock B. So the history of stock B indicates that his investment would grow at a rate of 11.9%, and it's compounded monthly. Okay. So we have 11.9%. So we're going to move that decimal 2 spots over, and we get 0.119. All right, and then it's compounded monthly. So there are 12 months in a year. So for compounded monthly, that means we would compound 12 times over the course of a year. Okay, so the only thing that's like missing from this table, well, I guess I should highlight stock B in green here, since that's where that info came from. But the other information that's missing from this table is the amount that was invested in each stock. So George contemplates investing the $15,000 he received from an inheritance, and he has 2 opportunities. Okay, so it doesn't tell us much more than that. So I'm going to assume for purposes of how much we're investing, that he's either investing the money in stock A or in stock B. So I'm going to say, well, I would either invest my $15,000 here, or I would invest it here. And we'll see which of these 2 options we like better. Yeah. Now, sometimes they might indicate that like he splits some of the investment between the 2, but since they didn't indicate that here, I'm going to summarize it like this for now. All right, so I've got a few now you try problems for you, similar to these 3 examples that we've done. So let me go pull those. And here you go. So this first one is kind of similar to that first one where we have like a bunch of percentages. The second one is like the last example where we can use a table to help us summarize that information. And then the third one is like the second example we did where there's like some unknown information that we might need to figure out. So again, we're not looking to solve this, and it's okay if you don't know what all the words mean. We're just trying to write down a summary of the information that is given to us. So in the next video, we're going to start to solve some problems. So we'll continue to make our summaries and then use the summary to help us, apply some formulas and techniques to solving. So looking forward to seeing you then. In the meantime, have a wonderful day.